So we've already covered parallelograms, and we talked about some properties of those last time. And what we're going to do today is talk about some special parallelograms. So these are all parallelograms, so they have all of those properties, but they also have properties of their own. So the first thing we're going to talk about is a rhombus. And a rhombus has three special properties in addition to all the properties of the parallelogram we already talked about. So if you remember, some of the properties of parallelograms are things like the diagonals bisect each other, and consecutive angles are supplementary. So if this angle and this angle together add up to 180, well, there's three more properties, and we're going to write them in here. So rhombuses are special parallelograms because a parallelogram does not necessarily have congruent sides, but a rhombus has all four sides congruent. In addition to that, when we draw the diagonals of a rhombus, they actually act as angle bisectors, and this is not true in every parallelogram, but in rhombuses, the diagonal actually creates two equal angles here, and then two equal angles over here. So the diagonals act as angle bisectors of the interior angles of the rhombus. Last but not least, when we talk about rhombuses, the diagonals are actually perpendicular to each other. That's a special property that not every parallelogram is going to have. Okay, so let's do an example with a rhombus here. So say perhaps that we were given this diagram and we know that it's a rhombus. So we know all these properties up here apply to this shape. So let's start by looking at angle 2, because I see right here I have an angle 35 and I'm not quite sure yet what angle 1 would be. So I'm going to skip to angle 2, and I know that the diagonals of a rhombus are angle bisectors of the interior angles, so I know that angle 2 is also 35 degrees. Now we're going to skip really quick and look at angle 5. So remember that opposite angles of any parallelogram, so you have to remember the properties of parallelograms from the last lesson, are congruent. So if this angle over here is congruent to this one over here, then we know angle 5 must be congruent to angle 2. The other way you can come to that conclusion is that you know in a parallelogram opposite sides are parallel, so angle 2 and angle 5, if we were to turn the page sideways, this would be a transversal, this diagonal, and they would be alternate interior angles. So we know that angle 5 is also 35 degrees. Alright, moving on from there, let's look at the two middle angles here, 3 and 4. So up here we learned that the diagonals are perpendicular, and if they're perpendicular, we know that both angle 3 and angle 4 must be 90-degree angles. Okay, last but not least, that leaves angle 1 and angle 6. Now same thing, because opposite angles in a parallelogram are congruent, and these act as angle bisectors, the diagonals, we know that angle 1 and angle 6 must be congruent. The other way you could come to that conclusion is you know angle 2 is equal to 35 degrees, and then both of these middle angles are right angles, so these triangles must have the same third angle. So if we do the triangle sum theorem, we know that all three angles in this triangle must add to 180, and add them up, subtract from 180, and you get the measure of angle 1 is 55 degrees, which we said is equal to the measure of angle 6. Alright, so we've done rhombuses. Now we're going to move on to rectangles. So rectangles are also special parallelograms, but they do not share the properties of rhombuses. So these properties do not apply to rectangles, only rhombuses. Alright, let's move down to rectangles. Alright, so when we come to rectangles, some of these are going to be obvious because you know probably more about rectangles and have seen a lot more of them in your life. So in rectangles, let's talk about the sides first of all. The opposite sides of a rectangle are congruent. The next one's going to be pretty obvious. You probably already know that all of the interior angles are right. Same thing as 90 degrees. You know that probably already. Last but not least, there's no special thing about the diagonals of a rectangle except that they are congruent. So diagonals are congruent. If we look back up to, let's look at this rhombus really quick. Can you see that this diagonal of the rhombus is much shorter than its other diagonal, which goes from opposite vertexes? In a rectangle, these two are congruent, and we already know from properties of a parallelogram that they bisect each other. So if I were to draw congruent symbols, all those tiny segments, all four of those, would be congruent. Okay, so there's not going to be much on a square, but I do want you to know that, we'll add it down here. A square is a composite, which means like a combination of a rectangle and a rhombus. So it has all of the properties of both of those. So not only does a square have diagonals that are congruent and opposite sides congruent, in fact all of its sides are congruent, it has all 90-degree angles, but it also has all of these properties, and you could check that by drawing one, where if we were to draw the square, the diagonals would be angle bisectors and they would be perpendicular. Okay, so we're going to do a couple of example problems together, and then I'm going to have you do some true-false for next time on your own. Okay, so we have QRST as a rectangle, so I'm going to draw that, and then to help myself, I'm going to put in some of the properties of my rectangle. So I'm going to make sure I draw my 90-degree angles. I'm going to make my opposite sides congruent by drawing different number of tick marks, and for right now I'm not going to draw the diagonals in, but we need to label our sides Q, R, S, T, and it doesn't matter which order you put the letters in. When we solve this problem, it may be that QR is actually the shorter side and maybe it went like this, but it doesn't matter for right now. Okay, so we know that QS is x plus 16, so you don't see a line segment QS, so you know that it must be the line segment connecting those two vertices. And if that's the case, then it's a diagonal. And RT is our next one, so I'm going to draw that in as well. Okay, what do we know about the diagonals of a rectangle? Well, we know that they are congruent. So I can set the two diagonal expressions, algebra expressions, equal to each other and solve. So I know that x plus 16 would be equal to 3x minus 4. We'll shift our variables in terms around to get 2x equals 20, and then x equals 10. Great, that's part of our problem, but we also need to find y. So we were told that the measure of angle r equals 2y plus 34. Well, since this is a rectangle, we know that the measure of angle r must be 90 degrees. So in order to solve for y, I'm going to set that algebra expression equal to 90 degrees. Oh, subtract here, 56 equals 2y, divide by 2, and we get 1, y equals 28. So in order to solve this problem, you have to know how to set up your algebra equation, and then also what to set the angle equal to, and that all comes from knowing your properties of rectangles. We just talked about this on the front page. I didn't realize it was back here, but if a quadrilateral is a square, then it is both a rhombus and a rectangle. It shares those. So I'm just going to summarize the properties for you. So all angles are 90 degrees in a square. You know this. Diagonals are congruent. All sides are congruent. The diagonals act as angle bisectors, and the diagonals are perpendicular to each other. All right. So just a couple more things for this set of notes, and then at the bottom I'm going to have you do the true-false on your own for next time. So it'll just be a couple of questions for you. All right, so we have ABCD is a square. I'm going to draw that for myself. And you don't have to draw in every property every time you draw a square. You don't have to draw all these tick marks and all these 90-degree angles, but you should know those properties, and I'm doing it right now for you because I want you to emphasize it in your studying so that you know all the properties. Okay, so A, B, C, D, and we are told that DAC is 9x. So DAC, we don't have, oh, I labeled these wrong, didn't I? No, I didn't. Oh, sorry. We don't have AC yet, so I'm going to draw that ray in so that we can complete DAC as an angle, because right now it's not drawn in. Remember that the middle letter must be the vertex of the angle. So here's our angle here if we wanted to extend that. Now you know from the properties of a square that the diagonals act as angle bisectors. You also know that all the angles are 90 degrees. I labeled that. If this diagonal is an angle bisector, then this little angle in here must be 45 degrees because it's half of 90. So I'm going to set 45 equals 9x, x equals 5. Pretty simple once you know all of your properties of a square. Okay, so we are going to do part of this chart today and part next time. So this is a summary chart to help you remember how all of these quadrilaterals relate to each other. So what we've been talking about so far are all of these shapes. And next time we'll talk about the unrelated ones like kites and trapezoids. So remember, quadrilateral simply means a polygon with 4 sides. So there's lots of different possibilities. There's our straight parallelograms, where the sides across from each other, opposite sides, are parallel. Can't fit that. And then underneath that we have special parallelograms. So a special parallelogram is a rectangle, a rhombus that we talked about today, and then the combo of both of those has all the properties of them is a square. Okay, so next time we'll talk about kites and all of those other. These ones do not have parallel sides, which makes them non-parallelogram quadrilaterals, and they're in their own category. Okay, so your job for next time is to just go through these true-false and answer them. You can use your notes to help you, but they shouldn't be too hard. All right, thanks.